For part B, we're asked what graph is traced by the equation x, comma, y equals 5 sine 12t, comma 6 minus 5 cosine 12t. How do the constants of this equation relate to Jamie's ride, and what does t represent? So I've went ahead and I've already inputted in the equation. To do that, you'd go to your graph and click menu, go down to graph entry edit and click on parametric equation as I already have, and it'll bring up this menu which allows you to input the equation as I did as follows. So once you've done this, you get this circle, and this circle is centered 6 units above the origin with a radius of 5. And this is exactly like the Ferris wheel in our problem, 6 meters above the ground, above the origin, and with a radius of 5. So we can take it to believe that this 5, preceding both the cosine and the sine, is equal to the radius of the circle. So then we have this 12t. So what does t represent? Well, to find that, we can go into our equation, and when we do, like let's say we input a separate value for t. In this case, let's do 15. So here we are given a point that still resides along the entire circle, but it is just a singular unit in point. So then let's try a different value for t. In this case, let's do 30. And here we get another individual point that remains on the radius. So we can find that over t amount, it changes the position of the point along the circle. So what indicates that in our equation? Well, in the Ferris wheel equation, we know that as time passes, the rotations happen. So we can take t to be a representation of time in seconds. Let's re-input the t's back here, so we can get our circular equation. And now that our circle is back, so we know that as seconds pass, the point along the circle changes. Jamie's location changes. So what does this 12 represent? Well, we know that in one full rotation, it takes 30 seconds. And it's 360 degrees in one full rotation. Divide that by 30 seconds and we'll get 12 degrees a second, which is synonymous with this 12 before the t. So this 12 is the number of degrees moved per second. So then we have this 6 minus 5. So this 6 is representing the point above the origin. It is a translation of the circle 6 units up, so we can see that the center of the Ferris wheel is 6 meters above the ground, the Ferris wheel. And that is what these represent. Of course, as we stated, t represents the seconds, 5 would be the radius of the circle, 12 is the degrees moved per second, and 6 is the translation up to show that it is 6 meters above the ground. That is part B. Cool.